Then we keep the timetable.
Yeah, David Wood, University of Calgary in Canada, qualifying the loads of small wind turbine blades. David, please, the screen is yours.
Okay, so hopefully you can hear me.
We can, yes.
And see my PowerPoint. And for some reason,
yes.
I've jumped to the conclusion. So everybody shut their eye for a moment. And I'll go to the beginning.
Yeah. Would you like to have it as a full screen? So that's much better. Thank you.
Yeah, okay. Well, thank you again. And as the last speaker, I'll try not to take too much of everybody's time. I'm from the University of Calgary in Canada, as was said before. I'm not an American, by the way. And I'm going to be talking about work that I have done with colleagues at the University of Newcastle in Australia, Sam Evans and Dave Bradley and Phil Clausen. I was at the University of Newcastle for many years, so this is sort of the outcome of work that I helped to initiate a number of years ago. And it was also done in collaboration with Scott Danner from NREL in Colorado in the US. And the two references to the work that I'm going to be talking about are given at the bottom of that first slide. So anyone who wants any more detail on the fairly brief presentation I'm going to give today, you can go to those two sources. The context of my interest in this work is the simplified load model in the IEC standard for small wind turbines. I've used it myself in designing wind turbines over a number of years, and I found it extremely useful for reasons that I'll give you some indication of as we go through the slides. The idea of the simple load model, as most of you will know, is that there are simple equations in it for the main loads that occur on small wind turbines, primarily the blades and the shaft. And those simple equations may have a considerable amount of unknown or uncertainty in it. And so we need to, or the standard requires that we use high load factors, as they call it, which are in fact safety factors to account for that uncertainty. And it's also useful to note that there's nothing comparable to the simplified load model in the standard for large wind turbine 61400-1. And the value of the simplified load model is primarily that it allows easy development of small wind turbines. And I think that is true even if the certification bodies decide not to accept it for design certification. The reason that it is valuable is that you can do all the calculations necessary for the simplified load model on a simplified Excel sheet. This is the final page of a 5-page Excel sheet that I developed with some colleagues quite a number of years ago now to implement the simplified load model for any small wind turbine. If you want further information on this, it's described in chapter 9 of my book on small wind turbines that was published by Springer about 10 years ago. And what you see on the screen here are the outcomes from the simplified load models for a 500-watt wind turbine, 3-bladed wind turbine. This turbine, I'll show you some field test results for that in a while. That turbine has never failed, despite the fact that the simplified load model indicated that there was a failure. I'm just looking for my pointer option, so I'll go to the laser pointer, indicated that there was a failure in load case B, which is basically the load case that deals with the yaw motion of a small wind turbine. And the combination of the yaw motion, the rotation of the turbine around the tower at the same time as the blades are rotating themselves, gives rise to gyroscopic loads on the blades and the blade shaft. And the simplified load model tells us in this case that the turbine would fail under that. And as I said, in something like 5 years of field testing of that turbine, we didn't have any failures. Okay, so what is wrong with the simplified load model? The main thing that is wrong with it is that the safety factors are too high. And I'll give you an example of that in respect to the gyroscopic loads in the next slides. If we look at another turbine that we've been involved with, a 5 kilowatt 2-bladed turbine, when we did the simplified load model assessment for that, the blades and the main shaft also failed for load case B that involves the gyroscopic moments. And as I keep telling anyone who listened, that turbine was installed in 2007 and has been operating safely since then. I will mention and talk a little bit about the gyroscopic loads and the safety factors, but I'm actually going to focus on the fatigue assessment, which is related to the gyroscopic loads. And I'll just make a note that there are some errors in the equations for the simplified load models. The error that we have found is not catastrophic in terms of changing its outcome in terms of fail or safe, but it is an example of things that should be improved. I'm going to be talking about fatigue assessment of a number of small wind turbines. The Aerogenesis 5 kilowatt on the right is one example, and another example is the Skystream 2.4 kilowatt turbine that's shown at the bottom picture there. Okay, just a few words about the gyroscopic loads on wind turbine blades. So here is the 500 watt turbine that I showed you the simplified load model spreadsheet for. That turbine clearly rotates in the clockwise direction as we're looking at the turbine here. At the same time, excuse me, as the wind direction changes, it is yawing about the tower, governed by the tail fin of the turbine. And this is a typical free yaw arrangement that is used in a large majority of horizontal axis small wind turbines. And that free yaw arrangement can give rise to significant yaw rates, a rate at which the turbine rotates about the tower. When you have high yaw rates and you have high rotation of the blades, then you give rise to gyroscopic moments on the blade shaft and also on the blades themselves. For this turbine here, we deliberately made the blades weak so that they would deflect substantially under loads, and we put strain gauges in the root area of the blade so that we could actually measure the root bending moment on the blade as it was in operation. And you can see down the bottom here a wind vane and an anemometer to measure the wind conditions. And here's some typical results on the right here. Wind speed between 6 and 10 meters per second, and equally important, the yaw rate measured in degrees per second is the blue line down here. And so you can see, for example, at somewhere around 2 seconds in this sequence of events, the yaw rate is maximized. And if we go up to the root bending moment results up here, you see that the envelopes shown in green and red for the gyroscopic moments are maximized at that condition. So high yaw rates, high rotation rates turn on gyroscopic loads, which are cyclic loads. The frequency of the cycles is the blade rotation frequency, and they're bounded by the non-inertial gyroscopic term 2J omega omega. J is the moment of inertia of the blade. Omega is the angular velocity of the blade, and little omega is the yaw rate, the rate at which it moves around the yaw axis. This is an exact result. This is simply a non-inertial load that comes from using non-inertial reference frames for doing the analysis. It is an exact result. It is accurate as shown by these results here. But if we go to the simplified load model in the IEC standard, we have to use a load factor or a safety factor of 3 for that load, which I think is excessive. Okay, so I'm going to move on to fatigue assessment because I should have pointed out the cyclic loads that are associated with the gyroscopic moments are also fatigue loads. And when we come to fatigue loads, we basically have three ways of doing a fatigue assessment in the IEC context. One is to use the equations in the simplified load model for fatigue. The second one is to do effectively what is done for large wind turbines. We use an aeroelastic model to simulate the loads, formulate the fatigue spectra, and do the comparisons of fatigue life. Or alternatively, after you've designed and built your turbine, you can actually measure the blade loads and determine the fatigue spectra that way. So I'm going to tell you about path number 2 for 6 small wind turbines, simulations that were done using the FAST software, which is well known particularly in the large wind turbine community as a valid aeroelastic certification tool for wind turbines. So just as a bit of background, if we do the blade fatigue assessment according to the simplified load model, we first of all have to calculate the number of fatigue cycles, which is equal to the number of blades times the design speed times the anticipated turbine lifetime, and then a factor because this is in seconds and this is in revs per minute. And then there in the simplified load model, there is a formula that gives the variation in the root bending moment. And the simplified load model assumes that that is a constant magnitude of the fatigue load, and it assumes that it is at a constant frequency determined by this equation up here. And I'm just pointing out at the bottom that if you do the basic scaling for wind turbine parameters, the design RPM scales in as the inverse of the rotor radius, so that clearly the smaller the wind turbine, the more fatigue cycles it's likely to experience. So here's the outcome of the fatigue load assessment for the 6 small wind turbines listed on the left here. Rated power from 2.4 to 50 kilowatts, a decrease in the design RPM generally, as you would expect from the previous argument. Here is the rotor radius, the number of blades, its configuration, and whether it has a tail fin or not. And as you would expect, the number of fatigue cycles tends to decrease as you go up in size. And that means that it's very difficult well, it's most difficult for the smallest of the wind turbines to deal with the fatigue issues. Here is the values of the magnitude of the fatigue load on the blades according to the IEC standard, and here's just a few of the symbols that I've used. Okay. So we used the FAST simulation with a representative range of wind speeds to calculate the root bending moment versus a fraction of the design life. So on this figure here, TD equals 1 corresponds to 20 years lifetime of this blade. In the sort of yellow color here, you see for this particular turbine, what the IEC simplified load model tells us the fatigue load is. From the FAST simulations in blue for the 5 kilowatt wind turbine, we get the results that you can see here. And we have proposed in the paper a modified equation for the simplified load model to more accurately reflect what actually happens. So what we see from the FAST simulations, because the blue line and the red line coincide at very small values of TD, there's a very small percentage of the turbine life where the loads are actually larger than the IEC specified load. But for the overwhelming fraction of the turbine lifetime, the fatigue loads are much, much lower than are specified by the IEC standard. There's quite a number of reasons for this. I won't read through this list because, excuse me, you can do that as well as I can. But there are a number of issues associated with whether the turbine's operating at design conditions, what are the effects of turbulence as the wind speed varies. The fact that the IEC specifications do not include the gyroscopic contributions to the fatigue loads, which are automatically included when we do the fast simulation. There are issues with variation in the rotor speed as well. And again, if you're interested in following up, this is actually taken from the reference that I've given at the bottom here. That reference gives more details on what I've said here, as well as the details for our suggested improved model for small wind turbine blade fatigue. So the conclusions are the simplified load model is a valuable tool, at least for preliminary design of small wind turbines. It can be significantly improved for estimating small wind turbine loads, and if those issues of excessively high safety factors, incorrect equations, and overestimation of the fatigue loads are dealt with, I think it would be made a much, much more valuable tool for small wind turbines. The main area for improvements for the fatigue characterization is in taking into consideration the gyroscopic load, because the fatigue modeling in the simplified load model is far too conservative. And we have proposed a less conservative model based on aeroelastic simulations for 6 wind turbines covering the size range of 2.5 to 50 kilowatts. So that is all I have to say about fatigue loads on small wind turbine blades. So I'll stop there and thank you for your attention.
Thank you very much, David. It's very interesting, and I'm sure there's a lot of look into for the blade manufacturers here. So I would like to invite for questions or comments to David Wood.
In response to Niels's comment, is it the von Miser in the chat? Is it the von Miser stress or the specific stress component? It's the von Miser stress that we based everything on. I suspect at the level that we're dealing with, discussion about which stress component to use is probably, a second order effect.
Yeah. Okay.
Yeah. Emmanuel Dawn.
I have a question, sir.
Okay.
This testing is the same resolve to the different materials on the blade, for example, the ceramic and carbon fiber and steel, wood. Please clarify. Is the strength of the resolve is similar to different materials or no?
No, because this work is all about the blade loads themselves, not about the material response to the loads. So the next part, once you have worked out what your fatigue spectrum is in terms of loads, then to determine the fatigue response of your blade, you need to feed in the relevant information about the blade materials. So that's the next step of the process. And clearly that is much more specific to the particular blade design than the methodology by which you get the fatigue spectrum.
Thank you. And Emmanuel Dawn.
Yeah, hello, David. Thank you very much
Hi.
for the very interesting presentation. Yeah, I just have a question regarding the wind turbines that failed in the calculations that you mentioned at the beginning, and that you said that in real life they didn't fail. But yeah, my question according to this would be whether you saw in your measurement data the conditions which are assumed in the simplified load calculations to really make a comparison.
Strictly speaking, no, but the difference between what a wind turbine actually sees and what the simplified load model assumes that it sees is an important one. So for example, the turbine that's been operating from 2007, it hasn't been operating consistently. It hasn't been operating all the time because it's a research turbine, and so it's lowered often for instrumentation and things like that. So for those reasons, we thought that it wasn't a useful comparison for a typical operating turbine to do the sort of analysis that you suggest. But I think it would be really nice to take you know, multi-year performance data from actual turbines to look into that issue, because what a actual turbine sees compared to what the IEC standard assumes is really part of the key of sorting this out.
Yeah, thank you.
David,
Yes,
yeah, David, excellent work.
Thanks, Mike.
We've recognized that the yaw rate assumptions were bad in the simplified model for some years, but nobody really wanted to do all the mathy stuff to get it all fixed and defend that against the original authors. And so we didn't do that. And part of the reason also was that we sort of found that the cost of aeroelastic modeling, consultants who will run fast had dropped to the point where you didn't really have to stick with the simplified models in their unrealistic safety factors. And so that's why we didn't fix the math. But I think we'll probably try to use your work, and for those who are using the simplified models, I think having better design numbers will help them make more cost-effective designs and not have to over-design just to meet the standard.
Agreed. They're very good comments, Mike. I got two answers to it. One is that I see this as a two-stage process. I see the real value of the simplified load model is when you're getting your ideas together about what turbine you're going to build. And at that point, you don't want to go to a consultant to run fast for you, because even if they're relatively cheap, that is a relatively expensive exercise. But even if you do go to someone that's going to run fast for you, the simplified load model can be useful in the preparation for that. The other thing I would like to say is a confession. I was actually partly responsible for the simplified load model. I wondered whether I would make that confession at the beginning of the talk or at the end of the talk. But the problem was, I mean, these equations, a lot of these equations came up about 20 or 15 years ago. We actually had very little information on which to base those. And, you know, I remember Craig Hansen coming into a TEC meeting with some data on yaw rates for small wind turbines. This was about 2004. And we all sat around saying, wow, isn't this a level of information that we've never had before? Now, the mistake that we made was something else that I forgot, or I deliberately neglected to say in the presentation. I think you and I have talked about this issue before, that you tend to get high yaw rates at low wind speeds. Okay, the highest yaw rates that we measure on our field turbines occur typically around 4 or 5 meters per second when the turbine is starting. When you get up to 10 meters per second and it's churning out full power, the yaw rates drop. So the multiplication of turbine shaft speed and yaw rate actually goes down with increasing shaft speed. But in 2004, we didn't know this. And so I think it's a highly understandable mistake or oversimplification that was made at the time. But now that we have significantly more information on how turbines actually perform, I think it is time that some of those oversimplifications can be corrected.
The other historical artifact was that the field test data was largely based upon downwind machines. And they didn't have the damping effect of a tail boom and upwind. So that was a contributing crime.
I agree. It's still, I think it's an interesting question still. How do you design a tail fin to minimize the yaw rate? I think that's still a valid question, because as far as I know, there's very little hard information on how you do that.
Right. And we're all getting smarter as we get older, hopefully.
Yes, the key thing is to pass it on to the next generation. Hopefully they're listening, Mike.
Hopefully.
Jean-Daniel, is he on? Jean-Daniel, you have a comment?
Yes, do you hear me now?
Yes, we do.
Yeah, no, I just had a comment regarding the Mike comment before about policies and only was talking, and I just wanted to complement it with and maybe we should have more effort on the marketing and publicity for small waves.
Oh, it's difficult to hear you.
Now?
Please talk into the microphone.
Yes, just a second. Let me put my headphones here. No, it's not working. Yeah. Do you hear me better now?
It's better now, yes.
Yeah. So no, I just wanted to compliment Mike's comment, but policy that we need to have maybe a little bit more on the marketing and publicity for small wind. Every now and then we
some new designs that promise to have huge efficiencies, and for many years, always promising something that never comes, but they actually get a lot of publicity and they reach millions of people because they are usually published in big media. So we just need to find a way to have more, to advertise better the products that we know are proven and are in the market. So I just wanted to mention that also, that we have to approach maybe also younger people through maybe social media, things like this, because at the end they are the ones who are now in the process of buying homes. So they're probably the future market for small wind are younger people. And if you go, for example, to some social media channels and you look for small wind, and there's nothing there, you don't see any picture, any videos, anything. So maybe we need to also approach that. So I just wanted to comment that, to add that to the discussion. But yeah, that's all.
Thank you, Daniel. Other comments or reflections or questions? Well, if not, then I will just say thank you to everyone and we are very happy here that so many has been on board to this conference, and I'm very happy about the high standard of the speakers in the conference. Thank you very much for that. And all the presentations will afterward be available at the homepage from Folkecenter. We hope that and expect to make another webinar conference. Depends on how the COVID-19 will react in the future. But we expect it to be in end of September this year.
See,
We'll see how it goes, but hopefully we can do that. But anyhow, we will also next year have the task conference here. Maybe you'll say a bit about
no,
that.
but
Sean.
it's always, Sean, he might be able to comment on it as well, but when you do market analysis and you want to give market data and things like that, it's very difficult when you have a meeting every 6 months or something. It's hard enough to get the data in a 1 year reference, even sometimes you even need more time to get a hold of all the feedback from markets. But whatever information, I would like to get back to that we have an agenda on having a market update from new countries. Now, yesterday we heard from Mexico. I think it was very interesting to hear about feed-in tariffs in Mexico and things like that. So whenever we can get hold of a new market report, get them on board and have them to present something from their country. It doesn't have to be perfect, but just some figures would be it.
Brazil is also coming on board, has been on board, and we also see that soon I think we'll see Colombia as well. There might be also other South American countries coming in, Middle American countries. So, and hopefully more African and Asian countries will participate as well, and even from Oceania. That'll be very nice too.
Yeah, so it's not all bad being on web, because it allows a lot of people, and not the same people that have an organization that can support you traveling. But these webinars allows a lot of people to join up free of cost.
Yeah, and I think actually that has been doing the conferences more lively, and there's a much broader audience or participation here. We know that more than 40 countries has participated, and more than 200 people. And we see from the beginning, we started out with the first conference, we were about 40 or 50 people from, I think, 13 or 14 countries, but it has really developed. And it seems as, well, it has been longer, and we have really widened out the presentations, and has really gone into details in different items and parts of the wind turbine, which I find very, very good for the small wind society, because we are now seeing that actually the manufacturers who can learn a lot from what is going on here, because seldom the manufacturers, who are normally people who are not really connected to the academic world, but this way they really will be, and they see what is going on and how they actually can get in touch with some of you if they need, because there are this, what I feel a great hospitality from all of you, saying that, well, please contact us and so on if there are questions. And I think that is very good for the small wind and medium wind society. And thank you very much for that, because that will give a better prospects in future for the small wind and medium wind.
I would like to add something.
Yes.
Do you hear me? Yes, just maybe a proposal for you for the Nordic Folkecenter. And nowadays it's very easy to do a online course on everything. You can learn Python. You can learn whatever you want now online. Maybe you should think about maybe having an online course. People pay for that, and for technical, and also on the projects. You say how to develop a small wind project. So just think about it, because now everybody's learning online, and it shouldn't be maybe too difficult. Also, usually the amount you pay is between $50 to $100 per course. It takes maybe 1-2 months, and you get a certificate. So just think about it. To have, there are many platforms now available for that. So that could be also an option to spread the word about small wind.
Yeah, thanks, John Daniel. That's actually something that we were looking at. Do you have any suggestion on which platforms? Because I've looked at different, and like some of them, it's quite difficult to get on board.
Well, I have used a couple of them. One is EDX.
Yeah.
It's usually many universities in the UA around the world, they use that. And the other one is Udemy, but I know there are many of them. But I know EDX should be not too difficult to have something there.
Yeah, it's just I tried to contact them already, but there was no answer on that. I think yeah, Udemy might be a little easier to get on board at least. But yeah, it is in work in progress. So let's see how far we can go.
Yeah, you can also check because EDX offers an open source software to have your own, let's say, learning thing. But it, of course, will be more difficult because you have to implement that. But you check that. Maybe you have the possibility also to build your own, let's say, learning space or platform.
Yeah, thanks a lot for the suggestion.
Thank you, Sean.
Yeah, just to comment on that, the wind empowerment community, which is the umbrella organization of all the DIY wind turbines and off-grid energy, they are also currently discussing or planning launch of a small wind turbine online classes, and they will most probably use Moodle, which is a software which a lot of universities here in Germany and Europe are using. And then I can also, if this goes online, I can also send a link to Tony or to Folkecenter to connect this.
Would be nice. Very kind of you. Thank you.
We had a presentation about wind empowerment in the last Congress from Luis Villa.
Yeah, and Costas was here yesterday.
Yeah.
As well.
So there's a possibility for cooperation. Don't do things, double things.
Of course, and also, Emmanuel, when this goes online, then you are welcome to put it in the LinkedIn group so that it reaches also a very targeted audience. That's what it is made for. So
yeah, I will keep it in mind. Good idea.
Yeah. There's a question from Niels Christian Olsen. Have anyone tried to regulate the air gap in the generator and use that as a brake? Question mark. Well, yeah.
In the U.S., Dakota wind turbines had a variable air gap. They're no longer offering turbines, but that was part of their technology. It was sort of a conical stator and a symmetrical conical magnet arrangement, and they could move the stator laterally and change the air gap.
Oh. Did it work?
What was that for a braking purpose, or was it for a variable flip?
It was for improved startup, and then I don't think it was used for regulation. Of course, if you open the air gap, you have less authority from the alternator to the rotor, so that's not good.
But if it comes together in high wind, you control the rotor.
Oh, if it comes together, then yeah, that rotor will come right to a stop. So
not completely together, but let's say it's moving closer.
I can show you plenty of evidence of that one. Yeah.
Infinite close.
Yeah.
Then there's a lot of brake.
No, but we for sure must think different. That's what the big companies are saying with the techniques, that we have to think out of the box to move cost of energy any further down. And that's also why we have had all this, especially university work with the different type of rotors. And it would have been so nice to be able to present some of these data from the dual blade or tri-blade. But the problem is when we work with universities that want to sell a patent and sell a concept, then and you sign an NDA, then it's not up to you whether you can present it or not. That's one of the challenging, but because there's a lot of people worldwide that's eager to get hold of or see data from for instance, a dual blade or a tri-blade. So let's see who buys it or where it ends. I have an idea, but I'm not allowed to tell. Then it's going to be interesting if they just buy it for keeping others away from the patent, or if they're actually going to use it, because that's what you see within the big wind, is that some companies they file a patent just to keep others away from using that technique, and it is ruining further development.
Yeah.
Yeah. Otherwise, the word is free. If somebody has anything to share, please do. There's still a little networking in this session as well.
Yeah.
Let me just mention that the Distributed Wind Energy Association will be holding its annual conference, business conference, and lobby day. We hold them in Washington. We have delayed it twice because of the COVID situation, but now we're scheduled for September 20th through 22nd in the Washington, D.C. area. It's a low cost. It's a great way to network with potential partners in the U.S., and we have part of the program that we dedicate to new products and new services. So we call it a lightning round. You have 8 minutes. It's almost like a sales pitch for investors. And this year we will also have a business development workshop for potential investors on the Sunday before, or the Monday before. Another aspect of our meetings is that we spend an entire day up on Capitol Hill visiting congressional offices in the House, Senate, different committees. We go to the White House, so we happily take foreign nationals along, and I think a number of people from Europe have found it very interesting to see how the sausage is made in American politics.
Yeah.
Hopefully
Nice.
without getting arrested.
Once again, please.
Hopefully without getting arrested. We're getting close to the White House.
Oh yeah, you have to announce sometime before. They have to do a security clearance. Yeah.
Is there a chance that the conference is also partly online?
Yes, we will. We experimented with that last year. We held ours only a couple of weeks before the pandemic really hit in America. But we'll have a virtual participation this year. So I'll be calling up Danielle and picking his brain for what to do and what not to do for this, because I think you put the Folkecenter's put together a very good platform here.
Thank you. We'll do our best.
Yeah, and if anybody else have awareness of something interesting happening in wind, which is not, then share it.
How are you looking at the next few years regarding small turbines? Folkecenter.
How we look upon small wind?
Yeah, the next 2 or 3 years.
I think we're just as challenged as the rest of the world regarding small wind. We'll have to. We need to have the politics change in order to get on board again. And some of it is actually our own fault. The feed-in tariff should never have been above the electricity price. That I think ruined a lot. So again, politics. But sometimes you're eager for this high feed-in tariff, and then it ruins your business case in the future. But as long as you compete with the replacing with the cost of the fuel you're replacing, then I think small wind has a business case.
And also, you must always be aware that small wind was meant to be self-sufficient for a family or a few families, and it has never been. Very few of them, anyhow. It's been meant to be something to go into, be a business in itself, and just generated money and producing electricity. And I still believe that the market will be for some kind of self-sufficiency or self-sufficiency in small communities. And therefore, there is still a big need for it. But it seems as the politician has made it difficult for small wind, but easy for big wind some places. But anyhow, in Denmark, it has stopped. There's no acceptance anymore for big wind on land. It has to be offshore, all of it today. And that they couldn't get enough. But we hope that people will again get allowed to have their wind turbines in the countryside in Denmark. So I think there'll be a chance for it. We're working on it anyhow.
Okay, I have a final question. Have anybody seen a small wind turbine coupled with a Tesla Powerwall, and so to make a house self-sufficient?
I haven't yet. I look forward to it.
Yeah.
And if you have an example, please.
No, I was asking because I was thinking maybe to get it modernized a little bit, to have a modern small wind turbine coupled with a Tesla Powerwall, and see if it was possible to sustain a normal household.
Of course, but depend where you're living. In Denmark, you'll find places with no wind, and you'll find places with a lot of wind.
Yeah.
So it's
maybe it could be an experiment.
But of course, it moves in that direction because as long as the batteries are getting cheaper and cheaper. It doesn't necessarily have to be a Tesla wall, but batteries in general are playing a bigger and bigger role.
Yeah. Yes.
But as long as you move towards battery types of LiPo4 or whatever, and you have removed the risk of putting everything on fire, then because you start seeing lithium-ion batteries inside houses and things like that, then it's challenging. But I think the LiPo4 gives other perspectives.
But I was very glad to hear that the net metering was working in Mexico. And we would really like to have it back in Denmark. And I think most of Europe and everybody could get an advantage of the net metering, because it's then it's having a very good purpose, and nobody can be against it actually. And it's cheap for everybody. It's cheap for the no bureaucracy in it. It's just to have 2 meters, one backward and one forward. And then you can once a year see if you should have a little money or you have to pay a little money. So if any of you hear about other places where they actually are using net metering, please let us know.
I also have to go. I'm going to be in the meeting with Mike Berge in 2 minutes. So thanks so much for a wonderful conference.
Thank you,
Likewise,
Brent.
Glad
we'll
you
see you
joined.
next time.
Yeah.
Yeah.
Thank
you for joining.
Thank you.
Yes, I also have to go.
Yeah.
Nice meeting you. I think there's a lot of old guys that I've never met before. That when I was digging deep into this, so now I got a face on you.
Well, if nobody else has anything more, I think that we'll just end the session and say thank you very much and wish you a good summer. And we'll see you in the early autumn, hopefully.
Early autumn or next spring.
Or next spring, yes. Yeah. But we'll see what we can do. And as mentioned in the beginning of the conference, if anybody has some ideas for support to continue these conferences, either by some sponsorships or other sources to come in, it will be very helpful. And every single dollar is welcome. Yep. Have a good summer, and you are always welcome to contact us here at the Nordic Folkecenter.
Thank you very much. Bye-bye.
Bye-bye.
Bye.
Bye.